description of motion of a body involves its position at any instant in time, its displacement, average velocity, instantaneous velocity or velocity, average acceleration, and instantaneous acceleration or acceleration. Let us learn how to represent these using vectors. First, let's start with the representation of the position of a body using vectors. Consider a body to be moving in the xy plane, represented by the rectangular coordinate system. At an instant in time t, it is at point P, which has x, y as its coordinates. Join the origin O to point P with a straight line and draw an arrowhead at P. This line OP with its arrowhead represents the position vector r of the body at that instant in time t. From P, draw perpendicular lines to the x and y axis to indicate the x and y coordinates of point P. xi represents the horizontal component of the vector r and yj represents the vertical component of the vector r. This position vector r is written as r is equal to xi plus yj. Next, let's discuss how to represent displacement of a body using vectors. Consider the same body to move along a curve in the xy plane. The body is at point P at time t and at point Q at time t dash. R and R dash are the position vectors at points P and Q respectively. Join P and Q with a straight line. Display an arrowhead at Q. This line, PQ, with its arrowhead represents the displacement vector delta r. From the vector triangle OPQ, we can write r plus delta r is equal to r dash. On rearranging, we get delta r is equal to r dash minus r. Let this be equation 1. This displacement vector delta r is directed from P to Q, which is represented by the arrowhead. We can write equation 1 in a component form as delta r is equal to x dash I plus y dash j minus xi plus yj, which is equal to x dash minus x the whole I plus y dash minus y the whole j. Now let us see how we can represent average velocity of a body using vectors. Consider the same body to move along a curve in the xy plane. In this case, the average velocity of the body is the ratio of displacement and the corresponding time interval. Here, displacement is delta r and the time interval is delta t. As shown in the figure, delta r is substituted by delta xi plus delta yj. On simplification, we get v bar xi plus v bar yj. The direction of the average velocity is the same as that of delta r. Next, let's discuss the representation of instantaneous velocity or velocity of a body using vectors. Consider the same body moving along a curve in the xy plane. Instantaneous velocity or velocity is limit delta t tending to 0, delta r by delta t, which is equal to dr by dt. Let us conceptualize this limiting process. When the body is moving along the curved path in the xy plane, it is at point P at time t, at point P1 at time t plus delta t1, at point P2 at time t plus delta t2, and at point P3 at time t plus delta t3. The position vectors of these various points are P is R, P1 is R1, P2 is R2, and P3 is R3. The displacement vectors with respect to point P are at point P1. Its displacement is delta R1. At point P2, its displacement is delta R2. And at point P3, its displacement is delta R3. The direction of average velocity vectors are shown in the graphs. Delta T1 is greater than delta T2 is greater than delta T3. As delta T tends to 0, delta R tends to 0 and becomes tangential to the path at point P. The direction of velocity at any point on the path is tangential to the path at that point and in the same direction as that of motion. We can write the velocity vector v in the component form as shown here. Using the resolved parts of magnitudes of v in the x and y direction, that is, vx and vy, we can write v is equal to the square root of vx square plus vy square. And tan theta is equal to vy by vx. And theta is equal to tan inverse vy by vx. Next, let's discuss the representation of average acceleration of a body using vectors. Consider a body is moving in the xy plane. During the time interval delta t, its velocity has changed by delta v. Its average acceleration a bar is equal to delta v by delta t. On substitution and simplification, we get a bar is equal to axi plus ayj. Finally, let's discuss the representation of instantaneous acceleration of a body using vectors. Consider the body moving in the xy plane. The instantaneous acceleration or acceleration is limiting values of the average acceleration as delta t approaches 0. On simplification and substitution, we get a is equal to axi plus ayj. We can understand this limiting process by using graphs showing the motion of the body. Consider the body moving is located at point P at time t. P1, P2 and P3 are its positions after time. Delta T1, delta T2 and delta T3 respectively. The velocity vectors at points P, P1, P2 and P3 are drawn. For clarity, we have drawn 4 separate graphs. The direction of average acceleration, a bar, is same as that of delta v for all the positions of the point P. In all the graphs, we have used the triangle law of vector addition. As delta t decreases, the direction of delta v and a bar changes. As you learned earlier, average acceleration, a bar, is equal to delta v by delta t. In the limiting condition, As delta t approaches 0, a bar becomes A, which is equal to dV by dt.